Hi guys, Mark here, and today in the Advent of Code Challenge we're on day 10, and this day is all about a fun little sequence called the look and say sequence. Basically, the way to generate the next item in the look and say sequence is to read out the previous one. So if you have this 2 1 1 and you say you've got 1 2 and 2 1s, so the next sequence is 1 2 2 1. And basically all we're asked to do is to start with a given input, repeat the sequence 40 times, and then see how long our output sequence is. So let's have a look at doing that in C#. And so here I've got a enumerable.range so that I loop over this 40 times, and then I'm using an aggregate function to calculate one output from the entire input sequence. And the input to my aggregate is going to be an array of the starting sequence. So I take my starting sequence as a string, turn it into integers, and then into an array. And then in aggregate I've got my accumulate function, and I don't really need the second argument because all I'm doing is passing in an incrementing number from 1 to 40. Basically, I'm just applying the same operation 40 times. But the challenge in this problem is to group together adjacent numbers. I want to group together the first 3 1s, and then a group with just one element, another group with one element, and then a group with 2 elements. And there isn't really anything built into LINQ that would do this for you. But, as is so often the case, MoreLink has exactly what we need. And so I've added the MoreLink package, and the group adjacent method will give me a sequence of groups, giving me each of these adjacent elements batched together. And I need to tell it how it knows whether elements should be batched together, and in our case it's very simple because we're just grouping together on items that are the same, so the same number gets in a group. Once we've got our groups, for each group we need to actually output 2 elements into the sequence. We need to output the count of how many items are in that group and what the actual key of the group or the number of the group is, which I'm just doing by getting the first element. And so select many lets me turn each of the groups into a 2-element sequence, and then I can just put those groups back to back. And I turn it back into an array because the type of my accumulator is an array. Once I've done that, I can just count the number of elements in the final sequence to get my answer. And that works really nicely. So let's take a look at solving this in F#. Now the main challenge in F# is that there is no group adjacent method that's part of F#. I did do a little bit of searching around on the internet, and I found a number of examples of group adjacent implemented in F# on the FSSnip website. But I decided I would try and write my own, and in fact I don't really need a group adjacent, I just need a count adjacent. How many identical items are next to each other? And so I wrote this little function. Again, I did use mutable. I know that really in F# you're trying to avoid using mutable state, but this is really quite simple. I just loop through all the numbers, keeping track of what the current number and the current count is, and if the number changes I yield what the previous number and count was, and at the end I yield the final number and count. And so this allows me to implement a look and say function that takes in an array of numbers, passes it into count adjacent, and then does the same select many trick that we saw in C#, turning a tuple into a 2-element list, and then turns the whole thing into an array. And so with that in place, I can just use the same approach that I did in C# to count how long the final sequence is. I take my number of repetitions, I call fold, which is the same as C#'s aggregate, and I fold that into the look and say function, passing in my initial input array. And then we just send that to seek.length to get the final length. And this works fine. I get the same answers, of course, as I do in C#, Although the only unfortunate thing is it seems to run really slowly, much slower than the C# version. Now I don't know whether that's my LinkPad being slow. LinkPad doesn't seem to be able to run F# very quickly, but I'm not sure really what is the cause of the great performance slowdown, because really this is the same algorithm that I used in C#. Anyway, that's it for today. I'll probably have a look on the subreddit and see if there are any other cool tricks I could have used to solve this, and hopefully see you for day 11.